The process begins with the transformation of arid desert land into controlled agricultural terrain. Heavy machinery levels the surface, organic matter and soil conditioners are blended into the sand, and deep subsoil layers are broken to prepare for root expansion. Freshwater flushing reduces salinity, while engineers continuously test soil composition and structure. Groundwater wells are drilled, pumps installed, and solar-powered systems connected to filtration and distribution pipelines. Through coordinated engineering, irrigation and energy infrastructure are established, creating a stable foundation for large-scale banana cultivation in an environment once considered unproductive. In a sterile biotechnology laboratory, banana plantlets are propagated through tissue culture to ensure uniform genetics and disease-free growth. Young plantlets are transferred into controlled substrate mixtures and moved into climate-regulated greenhouses. Misting systems, environmental sensors, and automated monitoring maintain precise humidity, temperature, and nutrient levels. Seedlings are gradually strengthened through acclimatization, screened for uniform vigor, and prepared for field conditions. By the time they leave the greenhouse, each plant has developed a stable root system and a compact, layered pseudostem base ready for transplanting. Once transported to the reclaimed field, each banana seedling is planted into laser-marked positions within prepared raised beds. Soil moisture is verified before transplanting, and drip irrigation lines are positioned directly at the root zone. The young pseudostem is stabilized with enriched soil and mulch to conserve moisture. Automated irrigation cycles begin immediately, ensuring consistent hydration while environmental sensors relay data to the control center. During these early weeks, root systems expand outward into the improved soil as the pseudostem thickens and the first leaves unfurl under controlled desert conditions. As the plantation develops, irrigation and fertigation systems deliver balanced nutrients tailored to each growth phase. Engineers monitor salinity, chlorophyll levels, and canopy density using drones, soil probes, and multispectral imaging. Windbreak structures protect expanding leaves, while excess suckers are removed to concentrate energy into the main stem. Biological pest control and targeted treatment minimize stress and disease pressure. Beneath the surface, roots extend deeper into organically enriched soil, anchoring the increasingly robust pseudostem as the canopy approaches full coverage across the former desert landscape. Entering the reproductive phase, internal tissues within the pseudostem reorganize as floral structures initiate. Nutrient ratios shift to support bunch formation, and irrigation levels are carefully stabilized to prevent stress. The inflorescence emerges from the center of the plant, bracts lifting to reveal rows of developing fruit. Male buds are removed to redirect resources, and protective covers are applied to shield the forming bunch from sunlight and insects. Continuous monitoring ensures uniform fruit set across the plantation as bananas begin expanding in size and weight. Over successive weeks, the bananas enlarge and reach full curvature, supported by reinforced pseudostems and additional structural ties where needed. Potassium-rich fertigation enhances firmness and quality, while stability sensors monitor trunk stress. When maturity indicators align with field data, harvest is scheduled. Workers coordinate carefully beneath the heavy clusters, cutting each bunch while preserving plant structure. With the fruit removed, the remaining pseudostem stands ready for its next transformation. After fruit harvest, the banana pseudostem is cut horizontally and lowered to the ground. Its layered, fibrous structure is sectioned into uniform lengths and bundled for transport. Each lot is tagged for traceability before being loaded onto covered trucks. The convoy departs the plantation and arrives at the processing facility, where reception inspections confirm freshness and moisture levels. The raw plant material then advances toward industrial processing, marking the transition from agriculture to manufacturing. Inside the factory, banana stems are washed under high-pressure water to remove impurities before being sliced into standardized sheath strips. Mechanical extraction systems separate structural fibers from pulpy tissue, directing organic residue toward recycling streams. Extracted fibers undergo enzyme treatment to remove sap and lignin residues, followed by repeated rinsing and controlled pressing to regulate moisture. Warm air drying stabilizes the fibers without compromising strength, preparing them for refinement into textile-grade material. Dried fibers pass through automated parting systems that align and straighten strands. AI-powered inspection ensures uniform length and consistency, diverting substandard material for secondary processing. Approved fibers are twisted into continuous yarn using ring spinning machines, with sensors maintaining precise twist ratios and thickness standards. The finished yarn is wound onto bobbins and transferred for weaving, completing the conversion from plant fiber to structured textile input. In the weaving department, banana yarn is fed into high-speed looms where warp and weft threads interlace into durable fabric. Real-time inspection systems detect structural irregularities as the textile forms. Finished fabric rolls are wound evenly and moved into storage under controlled conditions. From reclaimed desert land to fully woven material, the process concludes with sustainable fabric ready for global distribution, a continuous transformation driven by engineering precision and agricultural innovation. From freshly harvested banana trunks arriving at the factory gates, the process begins with controlled unloading, scanning, and inspection. Each trunk is measured, trimmed, and cut into uniform sections before entering mechanical decortication. As rotating blades strip away outer sheets, long cellulose fibers are released from the moist, layered pulp. The fibers are separated from residual pulp, thoroughly washed to remove sap, compressed to extract excess water, and carefully dried under controlled heat until stable moisture levels are achieved. What enters the plant as a thick, fibrous agricultural byproduct is transformed into clean, aligned raw fiber ready for industrial refinement. Dried banana trunk fibers are wound, carded, and straightened to improve uniformity and strength. They are then precisely blended with organic cotton to balance flexibility and durability before being drawn into continuous yarn through high-speed spinning frames. Each strand is twisted under calibrated tension to ensure structural consistency. The resulting yarn cones undergo tensile verification before automated systems transfer them forward. At this stage, loose plant fibers have evolved into controlled textile yarn, engineered for dyeing and large-scale weaving. Yarn cones unwind and combine into thick rope formations that travel through sequential indigo dye vats. With each immersion and exposure to air, oxidation deepens the tone from greenish blue to rich indigo. Optical systems monitor color uniformity, while controlled drying stabilizes the dye layer. Friction and wash simulations verify color fastness before the dyed yarn is rewound into cones. Through repetition, chemistry, and airflow, pale cellulose yarn becomes the signature indigo foundation of denim. Dyed warp yarns are aligned in parallel across large tension frames and coated with a protective sizing layer to strengthen them for weaving. The prepared warp is wound into beams and mounted onto looms, where natural cotton weft threads interlace horizontally to form the classic diagonal twill structure. Under synchronized mechanical motion, fabric emerges continuously and rolls forward as finished denim. Inspection cameras and tensile tests confirm structural integrity before the rolls proceed to stabilization and preparation for garment manufacturing. Denim rolls are spread into layered stacks and secured by vacuum systems before CNC blades cut precise garment components. Robotic sorting organizes each piece by size and configuration, guiding them into sequential sewing stations. Industrial machines assemble seams, attach pockets, install zippers, secure rivets, and construct waistbands in a continuous production flow. Threads are trimmed, garments are turned and shaped under heat, and dimensional checks ensure alignment. Structured panels of indigo fabric gradually take form as complete jeans. Semi-finished jeans enter controlled washing cycles where enzymes soften the surface and stonewashing introduces natural abrasion. After rinsing and drying, laser systems create precise faded effects while preserving fiber integrity. Ozone treatment refines tone without harsh chemicals, and steam forming restores shape. Each treatment stage modifies texture, depth, and character while maintaining durability. The garment's final aesthetic is achieved through carefully regulated mechanical and chemical interaction. completed jeans undergo light inspection, tensile testing, color fastness evaluation, hardware endurance checks, and metal detection to meet export standards. Approved garments are measured, sorted, folded, and sealed in protective packaging. Cartons are palletized, wrapped, weighed, and coated before entering warehouse storage. From there, automated systems prepare shipments for international transport. Every stage verifies that structural strength, dimensional stability, and surface consistency remain intact. Pallets move from warehouse to shipping container through port handling and regional distribution centers before arriving at retail environments. Garments are unpacked, displayed, examined, and finally worn. The journey concludes where functionality meets everyday life. What began as layered banana trunk fiber passes through extraction, spinning, dyeing, weaving, assembly, finishing, and logistics, completing a continuous transformation from agricultural source to finished denim garment ready for use.